Hello friends, let's discuss the shape of molecules containing bond pair and lone pair. Okay, first is AB2E type. AB2E, it means it is central atom and these are surrounding atom. And this is lone pair of electron. Okay, so one lone pair, two surrounding atom, one central atom. And the classic example is this SO2. It has one lone pair, two surrounding atom and one central atom. Okay. Now the shape will be what? Bent. Why it will be bent? Because this lone pair occupies more space. It will occupy more space. So bond angle will be not exactly 120 degree. It will be less than 120 और ये होता है 119.5 degree. Clear? So it is bent shape और इसको बोल सकते हैं V shape or we can say angular shape. So here good question is like why the bond angle is less than 120? So because of lone pair bond pair repulsion is more than bond pair repulsion. This is the region that is making this bond angle less than 120 and you have to remember the bond angle 119.5. Moving to the next molecule, AB3 type. It means one central atom, three surrounding atom and one lone pair, and classic example is ammonia. Hybridization is sp3. So for ideal sp3 bond angle is 109.5 degree. But here we have one lone pair and we know that lone pair bond pair repulsion is more than bond pair repulsion. So this repulsion between bond pair and this repulsion between lone pair, this repulsion will be more. So this bond will be compressed and the bond angle will be slightly less than 109.5 and here bond angle is 107. So you must understand this. And the shape is pyramidal. In shape we don't consider lone pair, so it is like a pyramid. The shape is pyramidal. Okay. Coming to the next, AB2E2. And the classic example is water. We have one central atom and two surrounding atom and two lone pair. Again we have lone pair repulsion is far more than bond pair. So this lone pair will compress this bond. Okay, so bond angle will be significantly less than 109.5 and here it is 104.5. And if I ask you to compare between ammonia and water, why water bond angle is further less? Because there are one lone pair and there are two lone pair. So here it will be more repulsion, okay, and it will be compressed. So this is again bent V shape or you can say angular. This is again important. Coming to next is AB4E type. We have one central atom, four surrounding atom, and we have one lone pair. And classic example is SF4. And there are four, structure given, and we have to select the most stable, right? So basically, two structure given, this one and this one, okay, and we have to select the most stable. In the first case, lone pair, I have kept it on axial position. This is what axial position. So whenever it will be on axial position, it will face more repulsion. Dekho. Here it will be repulsion, here it will be repulsion, here it will be repulsion. These all bonds are at 90 degree with the lone pair. So 3 bond pair lone pair repulsion. Here it will be 3 bond pair lone pair repulsion. And if you put on equatorial, so these angle are 120. So here repulsion is negligible. Mainly this is 90, this is 90. So we have only 2 lone pair bond pair repulsion. 2 lone pair bond pair repulsion. So here in this molecule it is less repulsion. We can say less repulsion and hence it is more stable. So lone pair should be kept on what? It should be kept on equatorial position to minimize repulsion. So very important. This is extremely important for JEE and NEET. That this structure is more stable where the lone pair is kept in equatorial position so that repulsion will be less. Now coming to next we have AB3E2 type. It means one central atom like chlorine, 3 surrounding atom and 2 lone pair. E represent lone pair. Again we have 3 structure given and we have to select the most stable one. You know that ClF3 is what? T shape and previous one SF4 was what? C-shape. So out of these 3 T-shape, we have to select which one is the most stable. Okay. In the first case, we have lone pair at equatorial. So repulsion will be between this and this. So we have 2 lone pair bond pair repulsion. 2. Okay. In this case, if you see, this lone pair is at axial. So it will have this repulsion, right? Two lone pair repulsion here, and this is at equatorial. So this will be at 90-degree angle, right? So this one more repulsion, one lone pair bond pair repulsion. So total is three lone pair bond pair repulsion. So it is not stable. And if you go to here, it will be 1, 2, 3, and then 4, 5, 6. Lot of repulsion here. So this is the most unstable. So the most stable is the first one, where both the lone pair is at equatorial position, and that is the best one. So this is the correct arrangement of lone pair and bond pair around the chlorine. That it is. Thank you.